Hello everyone, let's jump into OSPF packets, and we get to talk about these link state packets that have a couple cool functions. To start off, we've got the type 1 packet, and this is known as the hello. The hello is used to establish and maintain adjacencies with other OSPF routers. Your OSPF router is going to say hello to another router on a link. This is used to discover those neighbors and build those adjacencies, which are being used with keep alives to keep track of the neighboring router. The next one is the type 2, and the type 2 is the DBD. That's the database description packet. This contains an abbreviated list of the sending router's link state database. It is used by the receiving router to check its link state database against the sender. These link state databases must be identical between both routers within the same OSPF area. Our type 3 packet is the link state request, known as an LSR. And this is used to request more information from another router about an entry in the database description message. The type 4 is the link state update. This is what we send as a response to the LSR. Someone sends you a link state request, you respond back with a link state update. You're announcing either new information or you're sending what was requested from the LSR that you received. Now, a link state update can contain several different types of link state advertisements, known as LSAs. Type 5 is going to be the link state acknowledgement. The LSAC is actually able to acknowledge every other OSPF packet type except for a hello. You don't ACK a hello. And also we don't ACK an ACK. Those would be a forever acknowledgement going back and forth. So link state acknowledgements are awesome for acknowledging other packet types that aren't hellos and aren't acknowledgements. So let me jump into the OSPF link state updates. And first we're talking about those type 2s again. That type 2 database description packet, that thing is an abbreviated list of the sending router's link state database. And this is important because then we have that request, which is going to come up from another router saying, I saw your database and there's a specific item I need to know more about. And then we come to this, the link state update. That update is going to be in response to that request, or it's going to be an OSPF created message regarding a new network or something that's changed that's going on. Now, that link state update, as we mentioned, can contain many different types of link state advertisements. There's actually 11 different types of OSPF version 2 link state advertisements known as LSAs. I have them here on the right side. Now, these LSAs are the different message types that you might have a router receiving, which is part of an LSU. Now in CCNA here we really focus on 1 through 5, but we could go from 6 through 11, which is more of the advanced areas. So let's jump into an OSPF hello packet, and here we have it broken off into two sections. We've got the OSPF packet headers section itself and the OSPF hello packet section. Now, just a key reminder here, the hello packet is used to discover our OSPF neighbors and to literally maintain neighbor adjacencies. We've got a keep alive coming into play with this idea of a hello packet. Also, these hello packets include parameters that must be agreed upon in order for two OSPF routers to actually become neighbors. And lastly, when these hello packets run back and forth between two OSPF routers, they're also used in the election of the DR, the designated router, and the BDR, the backup designated router. This is only on those multi-access networks using technology like Ethernet. Point-to-point does not use DRs and BDRs. So let's talk about some of these fields. Here inside of our OSPF packet header, we've got a couple different things that come into play, such as type. And the type at the top is going to inform our router if it's going to be a hello packet, a DBD, an LSR, an LSU, or even an LS acknowledgement. We've got the router ID field, and that is going to have a 32-bit value in dotted decimal notation. It'll uniquely identify the router that's created this hello message. We've got the area ID, which is about the OSPF area number from where the packet originated. We've got the network mask, which is that subnet mask associated with the sending interface for this packet. We've got the hello interval. That hello interval is going to literally specify the frequency in seconds at which the router sends hello packets. Now that default timer on multi-access is 10 seconds. We're going to have the router priority. This is used in the DR-BDR election that we mentioned. The default priority for all OSPF routers is 1. This can be manually changed though. This is values of 0 to 255. The higher, the better in becoming the designated router, which is the DR. We've got the dead interval, which comes back into play with timings, and this is the time in seconds that a router will wait to hear from a neighbor before it says, "You neighbor are dead and out of service." By default, the dead interval is 4 times the hello. If the hello is commonly 10 seconds, the dead is commonly 40. The designated router, that DR, this is the router ID, the label name of the DR. The BDR, this is the router ID, the label name of the BDR. And lastly, list of neighbors is just like it sounds. This identifies the router IDs of all adjacent OSPF routers.